So here we go with a table of values. So this is 5.3, table of values. How do you go about determining? These are y's, right? This is like an XY table. And they're saying, okay, XY table, what kind of graph is that? Is that going to be, is it a table from a linear equation, an exponential, or neither? How do you know that? Well, linear, you know, is like y equals mx plus b. And exponential, that's what today's all about. That would be b to the x plus a. Let me just write it like that for now. The mark, the special mark of the exponential function is x is in power. So exponential, notice, exponential means x in the power zone. X is up there in the power zone, and you know linear. Okay, what does that mean about the table? Table means, for linear, y, this is linear here, linear, a line, y's, the y's add the same number each time. Whereas this exponential, the y's multiply the same number each time. What am I talking about? Well, look over here at this 3. Go 3 to 5. What did that go? What it added 2, huh? And then it adds 5. And then it adds 5. And then it adds 10. Is that adding the same number every time? No way. Is it multiplying? Maybe I should go back and look at multiplying. But no, what do you? There's nothing multiplying there. Right? What do you multiply 3 by to get 5? Or what times 5 is 10? 2. But what times 10 is 15? I don't know, something different. You know, it's not multiplying the same number every time, nor is it adding the same number every time. So this one's a neither. How did I come up with that? If you're adding the same number every time, you're linear. If you're multiplying the same number every time, you're exponential. I looked at these y values. This is doing neither of those. It's adding a different number every time. It's multiplying a different number every time. So it's neither linear nor is it exponential. Neither on that one. Good so far? Let's move along. Let's try another one. On this number 2, want to ask the same question. So looking at 1/3, so looking at the y values, 1/3, how does 1/3 become 1? How does 1 become 3? How does 3 become 9? How does 9 become 27? What's happening with the f of x or y values? What's it doing every time? Is it adding or multiplying the same number every time? It's timesing by 3 every time, isn't it? See that? It's multiplying by 3 every time. Because 1/3 times 3 is just 1. And 1 times 3 is 3. And 3 times 3 is 9. And 9 times 3 is 27. It's multiplying by 3 every time, isn't it? So what? What does that mean? It's multiplying by 3 each time. Same number each time. So that means it is exponential. It's exponential. The function is exponential. If it was adding the same number every time, that would be linear. If it's multiplying the same number every time, that's exponential. Okay? Now they also want me to come up with the equation. So what's it going to be? It's y equals, I'll write out again what I wrote a minute ago, b to the x plus a. B to the x plus a. B is the base. And the A stands for the asymptote. We'll get to that in a minute. How do you find the B and the A? Well, basically what you do is you come in here and you say, whatever that number you're multiplying each time by, that's your base. That's your base. So it's y equals 3 to the x plus a. So far, so good. Whatever the number you're multiplying by each time, that's your base. This would be a good thing to put in your 3x5 card for the exam. What is it, week after next on Tuesday, is to put this down. So the number you're multiplying by every time is the base. Okay, so how do we find the A now? How are we going to find that? The A, so I'm right here, B is number multiplied each time. And the a is number next to x0. What's across from x0? Here's x. 1. That's your a. So the a is 1. It's always what's next to the x0 in the table. Why? It's always best if you know why. There's too many stinking rules to remember them all the time. Way better if you get the why. Why? How do you just know that? If I take that equation, y equals, write it down here. If I take that equation, suppose I don't know what that a is yet. Suppose I'm still at the, it's 3 to the x plus a, and I don't know what a is. If I plug in x0, if I put in 0 here for x, what is 3 to the 0? 1. So that's going to be 1 plus a. Oh, wait a minute. Am I confused? I think I'm confused. Yeah. No. That's totally wrong. It's just never mind. Good thing I checked for reality, because you can tell I'm not kidding when I say I don't remember. I just kind of figured it out as we go along, and I clearly remembered it wrongly. So a is not that. Let's pretend I never said that. It's too bad this is being recorded. All right. So a is not that. If we need an a in a minute, then I'll give you a rule. But for now, it's just b to the x. I can't remember. I know this one is just 3 to the x. I mean, I know that much. I can tell just by looking. That works. That works. Yeah, you know what? You know really how I do it? Like I keep saying, you can tell I don't remember this stuff. Even though I teach it every semester. You think I would remember it, huh? I just figured out. I'm just looking and going, look, I know that's 3 to the x. How do I know? Well, if you plug in 0, you get 3 to the 0. I'm just kind of making tables in my head as I go. I'm just saying, does that work? It does. 3 to the 0 is 1, huh? What about if I put in 1? 3 to the 1 is 3. Yeah, it's working. If I put in 2, what is that? 3 to the 2, 9. Yeah, I know it's 3 to the x. That's the best way. That's really the best way. There's too many rules, obviously, to remember, even for me. Who teaches it all the time. Just work it out. That's working, isn't it? 3 to the x is working. The b always will be the base will be the number you multiply by every time. So this one's just 3 to the x on that. Good? Good to there sometimes? Good to there so far? And yeah, I do remember now what the other thing is. Sometimes there's a number multiplied here. Call it c or whatever. That's the number across from x is 0. In our case, it's just 1. I'm not even sure they're going to push us that far. Let's see. Let's see if... Okay, try that one. What's being multiplied every time? Yeah, it's not multiplying, is it? It's adding every time, huh? What's it adding every time? 4. It's adding 4, huh? So what does that mean? Is it exponential or linear? Linear. This one's linear. This one's linear because it's adding the same number. So if it's adding the same number every time, that's linear. If it's multiplying the same number, that's exponential, right? So multiplying the same number, that's b to the x times c. If it's adding the same, and when I say adding, I mean adding or subtracting, right? Positive or negative. Then that is mx plus b kind of thing, linear. Guess what that number you're adding every time is? It's the m. So m equals number added each time. So this is going to be y equals 4x plus, and guess how you find that b? Number next to x0. So it's kind of like for the exponential. The part with x is the number added every time, just like over here, the part with x was the number multiplied each time, right, for the exponential. And the other number off to the right is the number next to x is 0, which would be 6. You can see why, because if you plug in 0 for x, that m times 0 just goes away. It's just 0. And y simply equals b. So when x is 0, the y is b, isn't it? So the b is the y value when x is 0, isn't it? So it's 4x plus 6. So you choose linear 4x plus 6. But what's the best thing? What's the way to be sure, right? In the middle of the test, you want to be sure, right? What do you do to be sure? Because you can remember something partly wrong, like I just did. How can you be sure? Yeah, come up here and test it. Write 4x plus 6 and see if it's working. Put in negative 1. 4 times negative 1 plus 6. That's negative 4 plus 6? 2, yeah. Put in 0. 4 times 0 plus 6? That's 6. Yeah, it's working, isn't it? That's the right function. That's always the best way. Good on that? You could just test the multiple choice answers that way, couldn't you? It's a good thing to do. That's good. That's not cheating. That kind of thinking is the right kind of thinking. That's what'll take you far. Exponentials. And again, what is exponential? What does exponential mean? It means x in the power zone. So specifically, what if you had like x squared? Is that exponential? No, not exponential. Even though it has a power, x is not in the power zone. Do you know what I mean? Everybody with me on that? I want to distinguish that because if you're going to calculus, there's a whole different way of doing what's called the derivative for exponential versus not exponential. So you have to be really clear in your mind what an exponential function means. I'm not normally into the names, I don't really care. But in this case, it'll really help you. So it specifically means x itself has climbed into the power zone. X itself is up there in power. See how all these have x in the power zone? They don't just have powers. They have x itself in the power zone, don't they? All of them. That's what we mean by exponential. Things happen very fast with exponential functions. Their growth is explosive. You might hear it you read some kind of news thing on the internet or whatever. They'll say, da-da-da's growing exponentially. I mean, it's rocketing up. That because x is in the power zone. Just think about the phone. Let me just do a simple function like 2 to the x. That looks like, is that really that dramatically big? It actually is. If you were to make an xy table and put in like 0, you'd get 2 to the 0. Put in 1, 2 to the 1 is just 2. Put in 2. Let's just go, 2 to the 2 is 4. Put in 3, 2 to the 3 is 8. That's not that big. Let's just go to 10. I'll just jump up to 10. What if I'm trying to make a graph, right? Over 0, you don't need to write this down. I'm just giving you a feel. Over 0 up 1. There it is. Over 1 up 2. I'm just trying to graph right now 2 to the x. Y'all with me? I'm just making a quick table for graphing. Over 2 up 4. See what I did? I plugged in 2 here, and 2 to the 2 is 4. Over 2 up 3, 4. So it's going up like this. Over 3 up 8. Now it's 5, 6, 7, 8. Up here at 8. Over 3. Boom. Over 3 up 8. So it's 2. Let me jump to 10. I'll just go over here to, where's 10? Right here. 4, 5, 6, 7, 8, 9, 10. How high is it at 10? 2 to the 10th. What's 2 to the 10th? 1,024. Do I have room for that on my graph? This is 8. No. I'm not even I can't even get to 20, let alone 100, let alone 10 hundredths, which is 1,000, and it's just past that. See how much it rocketed up? It exploded, didn't it? By 10, it's already, through up to the sky. It would be if this was, spaced out right. Right? So that's crazy explosive growth, isn't it? Exponential functions. When x is in the power zone, things just take off. They rocket to the right and the left. All right. So with that in mind, that's what today's about, exponential functions and how they rocket up to the right or down, depending on how things turned or twisted or whatever. So let me give you a general game plan for how the things look. So if you have y equals b to the x times c plus a. I'm going to put them all in there now. Now we need all the pieces in the puzzle. So the a is a super important part. That stands for asymptote. Horizontal asymptote. Flat asymptote line. So these graphs, these exponential graphs, will have a flat horizontal asymptote. Every one of them will. And what it is, it's whatever that number added or subtracted off to the right is. So let's look at let's look at our graph here. Our graph, where's our horizontal asymptote? Right there. Y equals 0. Erica.
How come the plus a wasn't a part of the equation, like,
For those other table ones, yeah. They made them all 0. They were making life easy for you in those tables. They didn't want to make it too messy, so they just made them all 0.
So that's the original exponential.
Yeah, so in general, it can have 3 different parts. They made those table ones simpler, and they didn't give you the third part. They just made the a over 0. Because they wanted to make the table ones not too complex. But yeah, now that we're into the graphs, it's a good question. They'll have all 3 components.
So when we put in the answers for the other ones, we need to put like 6 to the x times 4 plus 0.
You don't have to write plus 0. It's just understood to be there because it's nothing. So, okay. So our horizontal asymptote is at y equals 0. So that means that's our a. Just like those table ones so far, it's a 0. So our thing is going to be b to the x times c plus 0. How do I know the horizontal asymptote's 0? So the a is 0. So really you can just skip it, huh, for this one. It's just b to the x times c, kind of like the table ones. Now, okay, so what is b and what is c? Well, the base, you can tell what the base is. All of them have what base? 7, right? They all have a base of 7. So this one must be a base of 7. But what about all those negatives and stuff? Yeah, let me give you the general, in fact, I think I need a fresh screen here. Let me give you the general setup on it. So getting back again to b to the x times c plus a. In general, they look like this. Let me give you the general picture here. They'll have a horizontal asymptote line at a. Ours is 0. And above it, it'll rocket up to the right and come down for a landing to the left. Now, I know ours is opposite, and we'll talk about that in a minute. But generally, that's what you get with the equation y equals b to the x times c plus a, is you get something that rockets up to the right, unless it's been flipped or something, we'll talk about that, and comes down for a landing on the left side, right? That's what the horizontal asymptote is. It's going to get closer and closer, flatten out to that, which is at a height of a, which is whatever number's added off to the right. Okay, so now that's the general. Remember the big 6 graphs we started off with? And I said, here's the general one, and then from there, they'll flip them and twist them and move them and stuff. Same thing here. So I'm giving you the general exponential, goes up to the right, rockets to the right, lands flat on the left, unless there's been negatives and things to flip it around. You know all those rules. So what is ours? What's been done to ours? They've taken ours and they've flipped it sideways, haven't they? They've not flipped it vertical. It's not going down, but it's been flipped sideways. Instead of going up to the right, ours is going down to the right. This one, down to the right, isn't it? And up to the left. It's been flipped sideways. What makes any graph, so if you take the y equals b to the x times c, we already know the a is 0 because that's the horizontal. What makes any graph flip sideways?
Negative x.
Negative on the x. So this must be, we know from the rules we've learned about, that'll see how powerful those rules are. They'll keep helping us through the whole course. That must be a negative x, huh? Because that's, remember, when you put a negative in the x zone, that flips sideways, doesn't it? So there must be a negative x there. We know the base is 7 because all the bases are 7. I'm just looking at them saying, look, they're all 7. So it must be like that. Okay. What's the c? Do we have any idea what the c is for our graph? Well, c is usually 1. What c is, let me give you the, right here. C is the gap. It's the gap from the horizontal asymptote to the point right there. To central point, let's say. To central point. C is that gap. C is how far from the horizontal asymptote to that point. Having said all that, that's probably too much. If I was doing this, if I was you, I would go, whatever, blah, blah, blah. I'm not going to memorize 10 million little facts. It's too much to clutter up my brain. I'm going to make a table. That's totally what I would do. So let me go back with you and make a little table. And so I'm going to say, okay, a little XY table. And again, we know the equation is generally of the form 7 to the minus x times c plus 0. That much we know, huh? And we're just looking for the c at this point. Y'all with me? How do we know? We know it's negative x because it's been flipped sideways. We know 7 is the base because they all have 7 as the base. And there's some kind of times c, and I know the 0 is the asymptote. So that's plus 0 because the horizontal asymptote is y is 0. Okay, so I just need to find the c. Well, just plug in a point. Look at what is this? Can you see the dot on the graph right there? That dot right there? Isn't that 0, 7? 1, 2, 3, 4, 5, 6, 7. Yeah, that's 0, 7. So if I plug in x is 0, I'm supposed to get 7. So if you plug in 0, 7 to the minus 0 times c, what is that? 7 to the 0 is 1 times c. What is c? It equals 7. C is 7. 0, 7. C must be 7. You're tracking with me. C must be 7 on that. Oh, that's kind of confusing, isn't it? Oh, yeah, this is a tricky one. Yeah, yeah. How can I make this easier for you? Yeah, because I know that when you plug in x0, you get y7. I'm just looking at the dot on the graph. So that means this, which is y, this, which is this, must equal 7. So C is 7. That's not the easy way, though. I know that's probably confusing. So, and then that's going to be hard. Yeah, I'm trying to do this as easy as I can for you. How about this? Yeah, okay, here's a better way. Let me do this instead. I mean, that's true and everything, but that's not easy. What's been done on this graph, they're being pretty tricky. What they've done on this graph, yeah, okay, here, let's do process of elimination. Yeah, I keep hemming and hawing, sorry. Let's do process of elimination. Is it 7 to the x? No, how do we know? Try it out. Try it out. I would just try it out. If it's y equals 7 to the x, you'll start learning quick, right? Put in a 0, you get 7 to the 0, that'd be 1. Over 0, up 1, no. That's not right. It's supposed to be over 0, up 7. So no way. Oh, and by the way, it's supposed to be a negative x, huh? Yeah, just get rid of that. Get rid of that. It's supposed to have negative on the x, aren't we? We already decided that. We're supposed to have negative. We know it's 7 to the minus x times c plus 0, right? We know that much. So no way on A, because the x power is positive. It's not supposed to be negative. No way on C. No way on E. Now, G's a maybe. It has negative on the x. Let's come back to G. B's a maybe. It has negative on the x. D's a maybe. It has negative. No way on F. No way on H. They don't have negative on the x. Good so far? We're down to 3. B, D, and G. Aren't you glad I only give you A through E on the test? Right? A lot of options here. All right. So now, which one of those is really right? Let's test them out. Let's test them out. If I thought it was really this one, then let's test it. 7 to the 1 minus x. Is that right? Put in 0 for x. What are you going to get? Let's just try it out. 7 to the 1 minus y would equal 7 to the 1 minus 0. 7 to the 1, 7. Is that right? 0, 7? Beautiful. Yeah, that's it. And it's tricky. Let's just show that B is not it. How do we know B is not it? Well, if we made a little table for B, and we did 7 to the minus x, put in 0. 7 to the minus 0 would be 1. You think 0 power is 1? 0, 1? No. Put in 0 here. For D, let's do D. No, it's going to be negative 7 to the 0. It would be negative 1. No, that's not right. 0, negative 1? No, it's not D. It is G. G is the right answer. Yeah. That other stuff I was saying about the C and everything, it's tricky. If you're interested, here's why what I was saying is true, and yet this is also true. It's because there's the right answer. You can trickily rewrite that, this way. 7 to the 1 times 7 to the minus x. That's the same thing. Remember, same bases, powers add. That's the same thing as 7 to the 1 plus negative x, or 1 minus x, same thing. See how that's the same? Remember, and that's what I said. Remember I was telling you there's a 7 multiplied in the front? Well, that's the same as this. They just wrote it in a tricky format. Anyway, I probably totally confused you now, huh? Just all you need to do, I would just eliminate the ones that are obviously not it. You know, you got to have a negative x power because it's been flipped. And then just try these three with tables. And G it is. All right. Let's try this one. So right away, you know it's b to the x times c plus a is the kind that go up to the right. So see which ones you can eliminate right away. The base is obviously 4. They're all 4. What's been done to that graph? It's been flipped vertically, hasn't it? They flipped it down. Just down? They also flip it left. They do both or just down? Just down. See, if I took this graph, then I flip this guy down, he would go like that, which is exact. Oh, no, and sideways. Oh, I'm wrong. Yeah, I got to see it to get it. Yeah, if you just flip it down, it'll look like that, which would mean it go down to the right. This one's going down. So then they also flipped it sideways. It's a double flipper. See that? They turned it sideways and flipped it down. You all seeing that? They flipped it twice, vertically and horizontally. Either order doesn't matter. You can flip it sideways first and then down, whatever. They did both flips, didn't they? Everybody see that? If I just flipped it down, I would get the blue. And that's not what I'm seeing. Ours goes down to the left, not down to the right. So they also flipped it sideways. So double flipper. Now what does that mean if you've got a double flipper? That means you've got a negative on the x and a negative in front of the y. Both. Double negative. So it's not A. Let's start eliminating. That doesn't have any negatives. It's not C because that only has the negative in the y. It's not E because that doesn't have a negative on x or in front of y. It's not G because that has the negative on x but doesn't have a negative on y. This is working out great. It's not B. That has. I hope I'm doing something right. I'm getting a little nervous now. But I think I'm right. So it's not B. That only has a negative on the x. D looks possible. That has both negatives. It's not F. That doesn't have any negatives. It's not H. Boy, this was great. That only has a negative on the Y. Unless I'm just like totally wrong. This was great. Let's try. You know what I would do if my test was on the line? I'd plug in at least 1 or 2 points to make sure. Because I know I can mess up. Right? I'm a human. I mess up. I make mistakes. Oops, I shouldn't erase that. So let's just plug in. We've got some room over here. I would do 1 or 2 points. It's easy to get things, all these flips and moves to get them messed up. So is it right? Negative 4 to the negative x. If I made 0, for example, if I plug in 0, what am I going to get? Negative 4 to the negative 0. Now, oh yeah, let me help you guys. You guys try, this is important. This will mess you up. You guys, this isn't nonsense. Listen up for this. This is an important lesson here. Negative 4, let me do this a little more slowly. I just remembered that this is a mistake a lot of students make. Let me go back and do this real slow. Negative 4 to the negative 0. Let me give you 15 seconds. What is the answer to negative 4 to the negative 0? 15 seconds. There's a lesson to learn here. Maybe 10 seconds. Negative 4 to the negative 0. You can't mess this up or it'll mess you up. What's the answer? Negative 1. You got to know it's negative 1. Really, really, really important. All these little things matter a lot. Why? Why is that negative 1? You might be thinking, sorry, you told us anything, right? Negative 0 is just 0, right? Right. True. I agree. That's the same as that. And that too is negative 1. Why? You said anything to the 0 power is 1. That's true. Anything to the 0 power is 1. That negative is not being raised to the 0 power. Only the 4 is. Do you know that? Really important rule. In other words, it's really picky. It really means this. That's what it really means. The negative is not part of the 0 power thing. It's not. The negative is saying, I'm not involved in that 0 power thing. I'm just sitting in the front. And the 4 is being raised. And I know you tend to look at it and go, no way. That's negative 4 to the 0 power. No, it isn't. It's like a negative outside and then 4 to the 0. Now, if they put it like this, how about if they did that? That would be 1. That would be positive regular 1. This would be. Right? I'm probably confusing you by writing it on the same line. Let me change it. If they did that, that would be positive 1. This is negative 1. Does everybody see the difference? Right? Because the rule is still true. Anything to the 0 power is 1, but but the question is, who's being raised to the 0 power? Right? In our case, only the 4. So if there's no parentheses, then only the immediate number, not even the sign, is included in the power. Y'all catching me on that? Because if you're not clear on that, it'll mess you up again and again and again and again and throw you into all kinds of confusion on these problems. It'll come up a ton. So, if there's no parentheses, only the immediate number, not even the sign, is involved in the power. Was there a question on that?
There was, but you answered it.
Good, okay. Does that make sense? Because you know what it's like, if this helps? It's like there's a -1 sitting in the front. That's kind of what that minus is like. It's like a separate -1, and he's not being raised to the 0 power. All right, so with that in mind then, so watch out. A lot of people mess that up. I'll keep trying to point that out as we work on these. So this one's -1. Is that really where it is? Yeah, it is, huh? Over 0, down 1. It's perfect. You can do one more if you're interested. Put in 1 or whatever. Get -4 to the -1. If you want to test one more point. What is -4? What's 4 to the -1? Do you guys remember what negative powers do? Flip it. So it'd be 1/4. Remember that? Negative powers flip things. Remember that? So that's -1/4. Does that look about right? Over 1, down a little bit, like down 1/4. Yeah, that looks perfect, doesn't it? That's the right answer.
How do you know that the base is -4?
How do I know that? Well, they all have base 4. So I know it's because they. Like how would I know if I didn't have the thing? Yeah, you would have. The only way you'd have to know is by something on the picture, by graphing a point. So I would look probably right there, and I would say, look, that's back 1, down 4. Yeah, that's how I would know. Back 1, down 4. Yeah, but they'll help. You don't have to. They'll give you pictures of where they all have the same base. But yeah.
What if you plugged in -1 on the table?
Yeah, sure. Let's do another one. So plug in -1. You're going to get, so the thing is -4 to the -x. So if you put in -1, you'll get -4 to the -1, which is -4 to the 1, which is -4. And there it is. Back 1, down 4. It's working perfectly. It's all good with that? So remember, again, powers only apply to the, 0 power, any power, only applies to them, not even the sign in the front, unless parentheses extend its influence. Right? That's a real important power rule there. Yeah. In fact, let me mention power rules for just a minute. Because if you're good with the power rules, that's a lot. So anything to the 0 power is 1. Anything to the negative, like -p power or whatever, that's 1 over x to the positive version of that power. Do you remember that negative powers flip things? Do you remember that rule from algebra? Negative powers flip it, make it a fraction, and then the power becomes positive after the flip. Do you remember that? And so another rule, if you have like -10 to the 0 power, that's actually -1, and -10 to the 0 power like that is +1. Just want to make sure that's really clear. How about if I go -10 to the 2nd power versus -10 to the 2nd power with parentheses? Yeah, getting it? So because the negative stays, and here it's positive because it's included in the squaring. Good on that? So you guys got the moral of that story? So if there's parentheses, then the power applies. If there's no parentheses, then the power does not touch the sign in the front. So if you're good on those power rules, you'll be able to crank them. Rudy? Oh, that's just true always for the power rules. But we'll use those power rules in these graphs. But yeah, those power rules are always true. Is that good? I better move on. There'll be. All right, try that one. Give that one a try. Think about how it's been flipped. It's always good to have the normal. You put the normal one right on your 3x5 card. The normal one goes up to the right. That's the normal one. The normal one without any flips is up to the right. So think about what's been done to that one. How's it been flipped? Vertically, horizontally, both, neither? If you're not sure, just, remember I guessed it wrong. On the last problem, I was wrong at first until I drew it. Did you notice that? You see me mess up? So my point in that is, you should be careful because it's easy to mess up. So I would look and I go, I think it's just vertical. If I just flipped it down, it would look like that. Does that match? Yeah, down to the right. So it's just a vertical, isn't it? This one's just a vertical on that. Matthew?
Y equals 0, is that what we're starting from? Like, that point where it crosses the y-axis? Is that going to be 0, -1?
I think it is. Yeah, I think you're right. This is, yeah, because this is the axis, so this is 0, -1. Correct. Yep, exactly. Yeah, I put the asymptote up because sometimes it's not on the axis. Yeah, you're just saying what's theirs.
Because the numbers are 2s. And it's like,
Oh, yeah.
I'm having to count, wait, that's not by 2. It's
Yeah,
by 1.
you're right. Exactly, Matthew. Good eye. Yeah, they're going by ones even though they're not showing the ones. Yeah, that's right. That's right. Good. Yeah, so it's going down. So they flipped it down, didn't they? Vertical flip, only vertical, not a sideways flip. So that means there's a negative only in the front, not in the x, huh? So can you go through and eliminate a bunch of them and just plug in for the other ones on the left? So negative only in the front. So it's not A. He doesn't have any negatives at all. C looks possible. Not E. He doesn't have a negative in the front. That 5 is supposed to have a negative in the front. It's not G. He's got negative on the X. It's not B. He has negative on the X. It's not D because he has negative on both. We're not supposed to have a negative on the X. It's not been flipped sideways. You with me? It's not F. He doesn't have a negative in the front. H is a possibility. He has negative in the front of the 5, not on the X. That's possible. So it's one of those two. Everybody with me? It's down to C and H. Those are the only two that have negative on the 5 and not on the X. So just by the flip thinking, we know it's either C and H. It's either C or H. So which one is it? I don't know. Let me try one out. So I'll try C first off. And I'll put in 0. And I'll say negative 5 to the x. That'd be negative 5 to 0. What is, careful now, negative 5 to the 0? Negative 1, huh? That negative stays. Is that right? Yeah, that is. So far, so good. How about H, though? Would that one also work? I don't know. Let me see. Because if they both work for the first point, I'm going to have to try a second point until I can tell which one works and which one doesn't. I don't think this one will work, though. Put in 0, you get 1 minus 5 to 0, 1 minus 1, 0, 0, 0. No. He's out. He's trying to make the point 0, 0. That's not on my, 0, 0 is here. It's not on my graph. So, C it is. Is that good? We happy with that? Getting the hang of those graphs. Questions I can answer? Do you like this? They're moving it. See if you can get it. I would still start by thinking about flips and stuff. Think about how this one's been flipped or not been flipped. About how it's been flipped or not been flipped. This one been flipped at all? It's not been flipped at all, has it? This one's just like the normal ones that go up to the right. It's still just going up to the right. It's like the total, no flips at all. So therefore we can go through and cross off anything that has negatives on X or on the base number in the front. So no way on C has a negative on the base in the front. It's a negative Y. That'd be a vertical flip. No way on G. He has negative on the X. No way on B. Negative on the X. No way on D. Negative on both. No way on H. He has negative on the 4 right here. That would be a vertical flip, wouldn't it? So we're down to 3, A, E, or F. It's one of those 3. Oh, yeah. And look at the, we can get it right now if you remember one fact. What's the horizontal asymptote? -1. Remember the general form I gave you? I know I keep switching it and stuff. The A is, the asymptote is the number added or subtracted, not times, not the times number, that's C. The number added or subtracted, that's the asymptote. So that's -1. So you're looking for one of them that has a -1 added or subtracted. Which one has that? Only E. Right? A and F do not have a negative 1 added or subtracted off to the right. F has one in the power zone, but that's not what we're talking about. I'm talking about the asymptotes on the base level. It's the number added or subtracted off to the right. So it's got to be E if we just know that fact. You can make a table and check, and that'd work also. Is that good? Like you can do these? All right, let's keep. So number 10, we have y equals 4 times half to the x. All right. Let's think about the flip. I think the flip thing is a good way to start. The normal graph that's not flipped goes up to the right, doesn't it? Exponential. See, x is in power. It's exponential. Normally they go up to the right. Okay. Does our equation, which they're giving us here, does it have any negatives anywhere? No, I'm just looking at this right here, which is what they gave me. No negatives, right? So no negatives at all. So it's not been flipped at all. So our graph should go up to the right. So no way. That goes down to the right. No way. And no way. I guess it's A. It's the only one going up to the right. Only A goes up to the right. All the rest have been flipped somehow. This flip thing's getting us a long ways. Is that good? You could check other points and stuff, and it would be right on that. Question? Chinu? What's that? Oh. Oh, you're right. I'm glad this is helpful. I'm wrong. Let's try this again. Just kidding about all that. Chinu's right. I'm wrong. Thank you. Bless you. Yes, I'm glad. This is so helpful when somebody's doing the homework alongside. Catch my mistakes. Yeah, this one's a tricky. You know what a half is? It's 2 to the minus 1. It's like a negative power. They're tricking us. When they give you a fraction, you got to write that half as 2 to the negative 1 power. That's the trick. Remember what we said when I gave you those power rules a minute ago? Right? Negative power is a fraction. Yeah, they're tricking me too. So when you see a fraction power, change it to a negative power, which means it's 4 times 2 to the negative x, right? Because you just multiply those, negative 1 times x. So it is a negative in the x zone. So that it's the same as a fraction is the same as a negative power, which means it's a negative x, which means it's been turned sideways, hasn't it? So it's not A. It's, normally the graph goes up to the right. So our graph is going to go down to the right. So which of them go down to the right? Either, it's B, C, or D. We have 3 options. We're going to have to plug in some points. Are you with me so far? All right. So now you can plug into the original one if you want, or this one. They're the same. They're 2 ways of saying the same thing. So I'm just going to make a table. I probably should have done that from the beginning instead of rely upon my tricks, because I wasn't so tricky. I got tricked. So fractions are negative powers. So plug in the 0. So what do we got? 4 times a half to the 0. Anything to the 0 power is 1. 4 times 1, 4. Over 0, 4. Which one has over 0 up 4? D. He's the only one that has over 0 up 4, huh? There, that was better. D it is. Is that okay? Want me to write that cleaner for you? Right, but we already know he's not. Yeah, good question. Yeah, good point, Matthew. We know he's not right because he's not been flipped sideways. Yeah, that's why it's not A. Good. So 4 times a half to the x. 4 times a half to the 0. I put in the 0. Is 4 times 1. Anything 0 power is 1, 4. So 0, 4. Yeah, A and D both have 0, 4. D's the one that's been flipped sideways because of the negative power. Yeah, good. If you weren't sure about, if again, you don't have to know that, you really don't have to know that fraction negative power thing. You could just plug in one more point. You could just put in 1. Suppose you were looking going, I don't remember all that fraction negative power stuff. I'm just going to do a couple points. That'll work for you. If you just did, you'd have to do one more point, though, to know whether it was A or D, because they both have 0, 4, don't they? If you did one more point, you'd get y equals 4 times a half to the 1. I'm putting in 1 now. And a half to the 1 is just a half. 4 times a half of 4, 2. Over 1 up 2. Yeah, this one was over 1 up 2. This one has over 1 up something big. So then you would know it's D that way also. Does that make sense? Either by plugging a couple of points or knowing the fraction is a negative power sideways flip thing. Either way. All right, watch out. Don't be tricked. That's why I did that, just to show you how easy it is. Okay. 5 to the x plus 2. Let me write a little bigger up here. 5 to the x plus 2 minus 2. Yeah, feel free to make a table. That seems to be the most reliable thing, huh? Do a couple points if you want. So I'm going to make an XY table. Put in 0. So this is 5 to the x plus 2 minus 2. Just get that out of the way. So 5 to the 0 plus 2 minus 2. That'd be 5 to the 2 minus 2. That'd be 25 minus 2, 23. 0, 23. That's a big one. I don't know. I'm going to do, no, that's a big one. I'm going to do 1. 5 to the 1 plus 2 minus, that's 5 to the third. That's 125 minus 2. That's 123. It's just rocketing up to the right, isn't it? It's hard to tell. Which of them, well, they all kind of rocket up. Well, not A. Yeah, okay, it's not A. A doesn't rocket up to the right. What's that?
Exponential to the 10th, right? Like times 10.
What's that about times 10?
Exponential times 10. Like the way you so the next one should be 10, 12, 30.
Oh, yeah, it's multiplied by 5 every time, because the base is 5?
Well, when you're doing like this 20,
Or what is it doing?
no, I'm wrong, because that'd be 230, so I know.
Yeah, I am. What I would do at this point is I would just plug in something like -1. Why am I coming to -1? Because as I'm going to the right, it's getting so big, I'm going to go to the left a little bit. So plug in -1 plus 2 minus 2. That'd be 5 to the 1 minus 2. That's 3. So back 1 up 3. Which one has back 1 up 3?
Well, you need a horizontal asymptote -2, don't you?
Oh, good. Yeah, we can do the horizontal. Good. Yeah, good observation. This is the horizontal asymptote, huh? Horizontal. Yeah, which one has a horizontal asymptote that's down 2? Right, down at -2, -1, -2. Horizontal, which one? Yeah, it's B. See how B levels off at down 2?
It also has the negative.
And it also has the back 1 up 3. It's B. Are we good on that? Is that making sense? Questions? All right, so that one was a little. Are you aware that E is just a special number, like pi is a special number? So, don't think it's anything amazing or special just because it's E. E is just 2.71. I don't remember. Boy, I'm getting old. What is it? Boy, it's funny. I always remember. Anyway, it's 2 something, 2.7 something. I gotta watch my own YouTube before class. Anyway, whatever. It'll come to me. I think. Anyway, it's not there.
2.718.
What is it?
2.7182818.
Yeah, 2.7, 1828. Okay, yeah. Anyway, so E is 2.7 something. Just like pi is 3.14. Blah blah blah. They're both numbers. So this is not right. It's 2.7. 1828. Right? It just continues. Well, it does that twice and then it breaks away. Anyway, whatever. So it's 2.7. So E is a 2 something special number. Pi is a 3 something special number. So it's just a number. Now, in calculus, you'll find out more about what E is and where it came from. It's something to do with exponential growth and compound interest and da-da-da. But anyway, for now, we just think, okay, it's just a number. It's a 2 something number. That's all E is to us, is a special 2 something number. So just go ahead and it's kind of like looking at 7 minus 2 to the minus x. It's like that. So what would you do if you had that? Tell me about flips. Talk to me about flips. Yeah, there's a negative on the x. So the normal graph goes up to the right. This one's going to go down to the right because it's been flipped sideways. And then what about this negative? And that's a vertical flip. So it's also, so grab this and flip it. Remember, you grab this like a rotisserie and you flip it. Can you see what's going to happen? It's going to go like that. Do you see that? You grab the axis like a barbecue rotisserie and you flip it, and that blue graph goes down to there, doesn't it? Do you see that? So this is the way it should look because of that negative and that negative. It's been flipped sideways and vertically. Which one looks like that? D. Now, I hope it doesn't throw you off that it's moved up. It has this shape. It's just been moved up to here. Do you see that? Only D. I don't need to mess around with points at all. D, done. Should you tell me I'm right? Is that right? Did you answer that one? Maybe I'm a little insecure too. That is right. Everybody see how I knew that? Just by the flips. I didn't need to mess with anything else. What is that 7 doing, by the way? That's like a 7 added to the back, isn't it? That's the horizontal asymptote, isn't it? Remember, the number added or subtracted to an exponential is the flat line, is the horizontal line. See how he has a flat line up there at like 7? Looks like? So that's correct. And he's going up to the right. Everybody good? Okay on the flips? So the flips tell domain and range and horizontal, so I should be doing that too. Let's do that on this one. All right, so try that one first off. Find out which graph it is. Can you read it there? So it's y equals 3 minus e to the minus x over 2. I would take that 3 and just go plus 3 in the back. Same thing, right? It's easier to look at that, easier to recognize that way. Is that good? So what's that 3? What's that plus 3? That's your horizontal asymptote, isn't it? That's your flat asymptote. You good with that? The number added or subtracted on an exponential, that's the flat asymptote. That's the horizontal asymptote, okay? So which ones of these has a flat asymptote at 3? Well, all of them except for C. C is the only one that flattens out somewhat negative. So it's not C. But the other ones look like they flatten out about 3. Don't they? So the other ones are still in the race. A, B, and D are still in the race. So, talk to me about flips. What about these negatives?
Either A or D.
It's gonna do 2 flips. So normally it's up to the right. It's gonna be flipped sideways and then vertical. Right, when you flip it about this axis. So it's gonna go like this. Which of them do that? Only D. Am I going too quick? Are you okay with those flips? Make sure you can do this yourself, because I'm kind of leading you through it, but make sure on your own you can think, get the flip right. Does everybody see why the flip is not like that? It's a mistake I often say. They think the vertical flip's like that. That's not the right. That's not a true vertical flip. Can you picture that? If you grabbed this line like a barbecue rotisserie and you flipped it, how this line would go like this. It would go the other way. Can you picture that? It would go like that. So that's why it's D. It looks that way. Good. All right, give me some feedback. I can't read. You guys give me the poker face today. Say yay or nay, shake it off, yes, no. We're about halfway through this one. Okay, so 10 to the x is 10 to the 7. What do you think x is? Yeah, isn't that a great one? That's a solve by observation. What does x have to be to make this? It's got to be 7. X is 7, solved by observation. There's nothing to do there. This is in the power zone. So, 2 to the minus x is 4. How are we going to solve for x there? What x value will make that true? Can you solve that one by observation? Can you just look at it and tell me what the answer is? Yeah. It's going to be negative 2. Because a negative 2 here would make it negative 2 would make it positive 2, and 2 to the 2 is 4. But anyway, we don't normally solve off. Let me give you a technique out there. I mean, if you can see that, great. Write it down. You're right. That's the answer. But But let me give you a method because they're going to get too hard to just look at in a minute. So let's come up with a method. So when x in the power zone. So the first thing is recognition. You got to recognize when to do this. When you're going to have so much stuff on the next test. Week after next, on Tuesday, we're going to take that test, and there's going to be so much stuff. How do you recognize this? X has climbed into power. So when X is in power, first, try to make the bases the same, then set powers equal. So that's step number one. Try to make the bases the same. If you cannot, or I'll say or ln of both sides, bring powers down to the front. So there's the whole game plan for when X is in the power zone. X is in the power zone. That's the big deal. You got to remember when X is in the power zone, it's hard to solve. It's a difficult problem, right? X is in the power zone. It's not just that it has powers, but X itself is in power, right? Everybody seeing that? Right? Everybody see that's the big deal? Let me, remember, I'm a wannabe history teacher, so if I can make history help math, serve math, because you got to remember, X is in power is the big deal when you got to do this. So, yeah, Matthew.
Just a quick question. I know, I'm assuming you're referring is the ln that's a log button?
Yeah, natural log, yeah.
Now, are we going to have to run into a scenario where we're not going to be able to do that like on a non-calculator portion? Or are we going to be able to have that available to us to use the rule?
Yeah, we'll get there. Yeah, you won't have to know natural logs off the top of your head. Okay. Yeah, we'll get there. Yeah, well, that first part you can use a non-graphing calculator anyway. Yeah. On that. So right, so any LNs you can just do with that thing.
Got you, right.
Yeah. Rudy.
What does that say on like where it says number 2 says or, comma,
Or LN.
That's your natural log button.
That's natural. LN both sides. Yeah, I'll get to that in a minute. I don't think we have any right now. All right, so let's try it. So you look at something where X is in the power zone. So you see X is in the power. You think, okay, I got to try to make the bases the same. How can I make that 4? Notice what I'm saying is, can I make that 4 2 to something? Can you write 4 as 2 to some power? Well, yeah, of course, it's 2 to the second power, isn't it? 4 is 2 to the second. That's just another way of writing 4. And why would I do that? Well, because then I've made the two bases the same, haven't I? And if you've made the two bases the same, well, then it's an easy question once you've made the two bases the same, because then you know the powers have to be equal. Why? Well, because if 2 to some power is equaling 2 to some other power, those powers have to be equal, or 2 to one of them wouldn't equal 2 to the other if they were different. Right? If I took 2 to the first, that's not going to equal 2 to the third, for example. Right? If the powers are different, no way 2 to one of them is going to equal 2 to the other if the powers are different, right? The only way 2 to something is equaling 2 to something is if those somethings, those powers are same, equal. Right? So as soon as you've made the bases the same, you know the powers have to be equal. And now how do you finish solving for x? Just divide by -1. So x is -2, which we had already stated. Does that make sense? So, again, you make the base, you take that 4 and say, I'm going to write him so the two bases are the same. Then you can just set the powers equal. Let's try. Okay. What I would do, yeah, this is a kind of a tricky one, a little bit. So as I'm looking at this, I would take my calculator and I would go, 3 times 3 times 3, that's 27, huh? And 4 times 4 times 4 times 4, that's 64. And then I would go, oh, you just multiply 3 times, right? 4 times 4 times 4, 3 of them make 64, and 3 times 3 times 3 is 27. So what power has to be up here? What does this power have to be? Has to be 3. Done. X has got to be 3. The third power makes that 64/27, doesn't it? Everybody see, I just looked at the top separately and the bottom separately. I just said 4 times 4 times 4 on my calculator. Yeah, it works. And 3 times 3 times 3 on my calculator. Yep, it works. So third power. Good enough on that one? Recognize this on the test. X has climbed into power. Everybody with me? X has climbed into power. So do what you need to do. What's the first thing you try to do?
Make the bases the same.
Look back. What did I write? So when X has climbed into power, what's the first thing you try to do? Make the bases the same. Huh? So make those two bases the same. Make them same bases. Try to make bases the same. X in power. That's called exponential. When X is in power, try to make the bases the same. This will be 5 squared. Good. And as soon as you've made the bases the same, then you can set the powers equal, huh? These powers now must be equal. You with me? Everybody good there? So those powers must be equal? So what do we do? And then you just solve it. Check 1, so 2x is 1, divide by 2. X is a half. Is that okay? Questions on that? Everybody seeing that? Maybe I can say to help on that? Do you see how there's no other easy way? Maybe it would help if I showed you that there's no other easy way to solve that thing. Do you see? Is that making sense? Maybe that's not occurred to you, and that would help. Think about it. If you didn't do that, what would you do? I mean, look here. I wrote it in. How are you going to get X alone? How in the world are you? X is in power. It's way up there in the power zone. What are you going to do? Divide by that 5? No, you can't divide by that 5. That's not 5 times 2x plus 1. That's 5 to the power 2x plus 1. You can't just divide off that 5. You see how weird it is? See how difficult when X is in the power zone? See how hard that is? And that's why you need these special techniques of making the bases the same, if you can. If you can't, we'll do the LN in a minute. Or maybe, I don't know if we do it in this section. All right? Okay, so... Okay, so again, see if you can make the bases the same. So you look at that, I'm assuming you're looking at that 64 thinking, is that 4 to something? Try it out. Take your calculator. Take 4, 4, 4, until you get 64. So if you take your calculator, 4 times 4 times 4 is 64, isn't it? So can I make those two bases the same? So X in power, base is the same. So 4 to the third, and the X is still there. You with me? See what I did there? I just made that 64 become 4 to the third. Is that good? And now, just cut out the bases, so to speak. Just set the powers equal. Everybody good to there? So we make the bases the same, and then we can set the powers equal. Because if 4 to something is equaling 4 to something, those somethings, those powers, must be equal, right? Yeah.
When you said it 4 to the third x power, wouldn't it be like 4 to the x?
4 what?
Wouldn't it look similar to
4 to the 3 to the x, like that?
Yeah.
Rather than 4 to the 3x.
Yes.
Good question, good question. Okay, 64 is itself 4 to the third, isn't it? So right where the 64 is, I replace it with 4 to the third, like that. So far, so good. And now, what's the rule from exponents of powers inside and outside parentheses? Like, what is 4 to the 2 to the 5? Is it 4 to the 10th? Do you just times them? Or is it 4 to the 2 to the 5th, which would be 4 to the 32nd? It's this one. You times powers. So it is correct to just times the 3 and the x. That's why it's not that way. Yeah, so when you powers outside parentheses multiply powers inside is the algebraic rule there. Yeah, so it is correct the way we've got it written. Is everybody good to there so far? Everybody seeing that? What's happened? So what did I do? I made the bases the same, then set the powers equal. Now, how do you solve this little equation? We're out of the woods. We're out of the power stuff. What do you do with x? How do you solve any x squared? Remember the game plan? Step 1, get a 0. Step 2, try to factor. Remember that? So you got to go right into that without hesitation. You got to immediately, instinctively know how to handle x squared. So as soon as you see x squared, we go into a whole new game plan. The power stuff's over. Now we're going into the x squared mode, and we go, oh, get a 0. So jump this 3x over here. Get a 0. Factor. How do you factor that?
Just pull the x.
Yeah, it's not 3 terms where you need the double parenthesis. It's not one of those. If it had a third term, if it was x squared minus 3x, minus 10 or something, then I would do the 2 parentheses, right? If there were 3 terms. You with me? You remember factoring from your algebra days? If it's just 2 things like this, I just take out what's in common. Good like that? Remember that? If you were to multiply that, it would go back. Good to there. And now, 2 things are multiplying to equal 0. What does that mean? If I say, hey, I'm thinking of 2 things, they're timesing to be 0. Either one could be 0, right? First one could be 0, or the second, right? If 2 things are timesing to be 0, either one could be 0 to make them times and be 0. So either one is 0. So this one's done. This one, move the 3 over. X is positive. We got 2 answers, 0 and 3. 2 possible answers. Make that true. They just want you to put a comma. Use commas to separate answers. 0, 3. No parentheses. It's not a graphing thing or anything. Is that making sense? Is that true? Let's go back to the original. If you put in 0, it's kind of a mess now. Back on the original here, if you put in 0 here and 0 here, is that true? Well, yeah. Anything to the 0 power is 1. So 4 to the 0 power does equal 64 to the 0 power because 1 equals 1. What about like 3? Does 3 also work? Put in 3 there. Put in 3 there. You can check it on your calculator. 4 to the 9th, 3 squared is 9, is 64 to the 3rd. It's the same thing. They're both right. Questions on that one? I better move on. Okay, so 64 to the 3x, 16, x plus 2. X in power.
Sorry, I'm in your business.
X in power. What are you going to do? Base is the same. Base is the same. Hey, if you, I assume what you're doing is taking your calculator and taking 16 times 16, and it doesn't work, huh? 16 times 16 is already something too big, huh? It's already bigger than 64. So what are we going to do? Use 4 or 2. Either one will work. Yeah, you got to make both of them out of something smaller. Does everybody see the deal here? You can't make 64 out of 16. It doesn't work. Try to calculate 16 times 16 is already too big. So then you go, oh, can I make them both out of something smaller? Yeah. Either use 4, that'll work, or 2, you can make it work. So how about 4? So make them both out of 4. So everybody see the deal there? Use the base 4 or 2. So this is 4 squared, right? 16 is 4 times 4. And 64 is 4 cubed.
So then you do that 3 times 3x, which would be 9x.
Everybody see what happened there? I made both of them out of the same base. Huh?
3 times the 3x, I think.
See that? And now, yeah, remember the rule from algebra? Powers outside parentheses multiply powers inside. So this 3x is going to multiply that, be 4 to the 9x. And this guy's going to multiply here to be 2x plus 4. Powers inside parentheses multiply powers
So
outside
that's right, then
parentheses.
the 9x equals 2x plus 4.
Get to there.
So then we have to get to 0. So probably
See what happened?
bring this over here.
And now you can set the powers equal. Huh? Same bases, you can just set the powers equal.
2x minus 9.
So this must equal that. 9x must be 2x plus 4.
That's what
How do we finish? Subtract 2x from both sides. 7x is 4, divide by 7. 4 sevenths. You good?
No, it's 7x. We didn't even have to
Question, yeah.
do anything. You did it like this to solve for x.
Say that again?
7x equals 4 divided by 7.
Put it in C. I don't know if we can.
Minus 2,
Or
minus 2x, you get 7x on this 7x plus 4.
okay, I do want to do another x squared one though.
4
Yeah.
7 is because there's no x squared there, so we don't factor.
Yeah, putting it on. Yeah, we're putting it off one meeting, right? It's not. Yeah, it's listed on the schedule for. It's going to be the 6th. It's going to be the week after next on Tuesday. Yeah, we're putting it back one meeting. So yeah, exam number 2 is the 6th, the week after next on Tuesday. All right, so try that one. Make the bases the same, right? X is in power again. Make the bases the same. Set the powers equal. And you're going to have another x squared equation.
It's already 4 on one side, so you just have to do the other side. 4 to the second minus x. 2 x squared minus 3 equals 2x. 3.
So everybody good? 16 is 4 squared, huh?
Yeah.
So now you can set the powers equal.
And you should negative 2 and positive 1, or negative.
Once you've made the bases the same, the powers must be equal.
Positive
3, positive 3, yeah. Oh,
And now,
negative
what do you do
yeah,
as soon
yeah,
as you see
bigger
an
one.
x squared equation?
Negative 3,
Go
positive
to the
1.
game plan as soon as you see an x squared equation. X squared with an equal sign. Step 1, get a 0. So first off, you got to get a 0 and then factor. Try to factor. If it doesn't factor, you got to do the quadratic formula, negative b plus or minus. I don't know if they're going to give us any of those.
Oh, I did it. Oh, no.
Everybody good like that? So whenever you see x squared, first get a 0. First get a 0, and then factor. How does that factor? 3 and 1. They multiply to be 3. And add. Remember, you multiply to be the back number, add to be the middle. 1 times 3 is 3. How do they make negative 2 in the middle? The sign in the middle always goes on the bigger of the two numbers. Are you aware of that? Am I going too fast? You remember factoring? Remember how factoring works? So the number at the back, when you have three numbers, you factor with the two parentheses. The number in the back, 3 times 1 is 3. Either order, doesn't matter, 1, 3, 3, 1, whatever. No signs yet. How do you know the signs? The sign in the middle always goes on the bigger of the two numbers. Who's bigger, 3 or 1? 3. So that sign in the middle goes on the 3. The other one's positive. Why? Because if you that's just simply what would work. If I FOILed this out, if I went boom, boom, I'd get x squared plus 1x, boom, boom, minus 3x minus 3. That'd make minus 2x in the middle, see? It would be right. So just if you're not sure, if you factor and you're not sure, just FOIL it out. FOIL it out until it's right. Just keep altering it till you got it on that. Okay, and then you set each one equal to 0 separately, don't we? Each one equal to 0 separately because the two things times to be 0. Either one could be 0 to make them times and be 0. Move that over. It's just going to be opposite sign, huh? Positive 3, negative 1. Positive 3 and negative 1 are the answers. 3 and negative 1. Is that good? Getting the hang of remember the x squared stuff and make the bases the same, set the powers equal. Good? Better move on, huh? It is a big section. So 9 to the x times 3 to the x squared is 81 squared. Yeah. Okay, you got to basically make all those out of 3. You got to make all those into 3 to something. Take that 81 on your calculator and find out how many 3s. You just go 3 times 3 times 3, you get 81. 9 times 9.
I used to know that for that morning. Don't use it, you lose it.
So, right, and then this part, and this 9, that's 3 squared. Is 3 to the 4th. Is that good so far? How are we doing? Is this making good sense so far? So 3 squared is 9. 3 to the 4th is 81. Good. Bless you. Now, the trick is, do you remember the rule from algebra? What happens over here? What if you have like 3 to the 2nd, say times 3 to the 5th? What does that equal? You add the powers. Remember that rule? You add powers. If you have x to the a times x to the b, that's x to the a plus b. That's different. That's one rule. The other rule is x to the a to the b. That's x to the a times b. You know those two different exponent rules from algebra? Remember, what pre-calculus is basically advanced algebra. I know you've seen these rules, but now you're really mastering them. So if you're timesing the same bases, you add powers. If you're doing powers to powers, you multiply them. So that means over here we're timesing them. So I'm going to add those guys. Over here, this is powers to powers. They're going to multiply. Everybody see how I put them all together? Now, finally, we can say this power equals that power. Now that we made the two bases the same. A single 3 on each side. Once you've made a single 3 on each side, same base, just one of them on each side, then you can say the powers must be equal. Because if 3 to something is equaling 3 to something else, those powers must be equal, or 3 to one of them wouldn't equal 3 to the other if they were different. Everybody tracking with that? Remember all those rules?
No. -4.
All right, so then, and now we have x squared. So you know what to do? What do you do when you see x squared?
Factor.
Get a 0 factor. Always get a 0 first, right? Jump that 8 over, so rearrange it. X squared plus 2x minus a to 0, right? X squared with an equal sign. Step 1, get a 0. Step 2, factor. How do you factor that? What multiplies to be 8? What times what's 8? 4 and 2. Where's the sign in the middle? Always goes on the bigger number. Sign in the middle always goes on the bigger number. Plus, minus. Plus 4 minus 2. Right? So then that means negative 4. It's just going to be opposite signs. Can I just jump to it? It always ends up just opposite signs from the parentheses, right? Plus 4 minus 2. There's our answers. Questions on that? We got 10. E to the x squared equals e to the 9x times 1 over e to the 20th. Okay. You know the deal. We've got to make it, you know the goal here, right? X in power. Make it e to something equals, or e to the whatever equals e to the whatever. That's the goal, right? Make it a single e on this side, make it a single e on that side, and as soon as you do, then you can set the powers equal. You got to make one e base. Remember, the base is the same. One of them. A single e on the left side, a single e on the right side, and then you can set the powers equal. So that means I got to do some algebraic trickery. What can I do with this? What is it? Good job. Do you remember that's negative 20? Remember, negative powers flip things? So they're pushing you now on all your knowledge of power rules. Obviously, it's the power section. So do you remember these rules from algebra? Negative powers flip things. So when I see that 1 over e to the 20th, I go, oh, that's just e to the negative 20. Right? Negative powers flip. And then, okay, so what? Well, then, next step, I can say, what do you do? Same bases multiplied. Remember the rule? Same bases multiplied. Powers add. I'm getting running out of room there. Let me move it down. Same bases multiplied. Those powers are going to add, aren't they? 9x plus negative 20, which really just means 9x minus 20. You don't need plus or minus. It's just 9x minus 20. Everybody see that? That's how I combine them on the right side. Same bases multiplied, powers add. Right? We saw that rule a minute ago. And now I can set the powers equal. Like that. Once you've made a single e, same base, each side, powers equal, away you go. How do you finish that? Can I go dot, dot, dot? Just got to jump that over. Well, maybe I'll do it real quick. Minus 9x plus 20 equals 0. Factor. What multiplies to be 20? 4 and 5. They're going to both be negative. Because you got to multiply to be positive. 22 negatives make positive. And they add to be a negative 9. So the answer is positive 4, positive 5. Those are the two answers to that question. Everybody see that? I jumped those to the other side of the equal sign. Got a 0, factored, and finished it up. All right. So remember how I wrote the rule, make the bases the same, and then if you can't, use the ln? We won't need that on this homework. That'll be the next homework, I guess. There's no ln ones needed. It'll be the next homework, though, so you'll use it. So here we go. They're giving me 8 to the x is 7. They're giving me that. And they're asking me, what is 8 to the minus 2x equal? What is 8 to the minus 2x equal? So how do you turn 8 to the x until 8 to the minus 2x? How do you do that? What do you got to put up here to make negative 2, right? Whatever you do to one side, do to the other. Does that make sense what I did there? Am I going too quick? They gave me this as a starting fact. And they said, turn it into that, please. And I said, okay, I'll raise it to the negative 2. But whatever you do to one side of an equal sign, if you're going to keep the balance, you got to do the same thing to the other side if you're going to keep them equal. So that means this will turn into 8 to the minus 2x. Remember, powers inside, outside parentheses, multiply. And the other side will become 7 to the minus 2, won't it? And they're asking me, what does 8 to the minus 2x equal, please? What does it equal? It equals 7 to the minus 2. But they want a simplified fraction. So how do you simplify that fraction? What's a negative power do? Flips it. 1 over 7 to the positive 2, meaning 1/49. Done. That was kind of a weird question, huh? It's weird that they asked for like a strange thing like 8 to the minus 2x. They gave me 8 to the regular x was 7. I raised both sides to the negative 2. So 8 to the minus 2x is 7 to the minus 2. Flip it, 1 over 7 squared, 49. 1 over 49. Back to graphs again here at the end. They're going to give me the picture and they want me to work backwards to the equation. Okay, let's try it. So it's going to be y equals b to the x times c plus a. It's exponential just by looking at the picture clearly. It's exponential. They're saying it's exponential. So I write down the general exponential form. There's no multiple choice here. Aren't you glad I give multiple choice on the exam? What if I said just write it in? That'd be kind of tricky, huh? All right, so we're going to try to write it in there. So what's it going to be? How do we write it in? Let's start with the a. What's the a?
0.
It's the asymptote line, which it looks like it's flattening out at y equals 0, doesn't it? Y equals 0. So that's just 0. That part's just 0, so it's just gone, huh? So it's just b to the x times c. Okay. What do you think the base is? Yeah, see all those 6's everywhere? The base is probably 6. I'll check it with tables in a minute, but it's a good start. It's probably 6. Let's try. Maybe let's just try 6 to the x, and let's see if that works. And if it doesn't, I'll adjust things. So here we go. I'm going to put in 0. I'm just going to take a guess at 6 to the x. When you put in 0, what do you get? 6 to the 0, which is 1. Over 0 up 1. Is that a point on the graph? Yeah. How about if you put in 1? 6 to the 1 would be 6. Over 1 up 6. Is that a point in the graph? Yeah, it's working. That's all it is. Is that too quick? Everybody see that? They didn't do too much fancy on that one. So you can try the other points. It'll work. You can put in negative 1. 6 to the negative. What's 6 to the negative 1? What's negative power do? Negative power flips it, right? That's the correct point. See how that's working? It's generating all those points, isn't it? You okay? You guys look like you're done. 6 more minutes. Hang in there. Okay, so what kind of a flip is that? That's a vertical. They normally go up to the right. This one's been flipped down, hasn't it? That's a vertical flip. What do you think? So it's y equals, what is it? B to the x times c plus a. What do you think what's the a? What's the asymptote line?
0.
Yeah, it's 0 again, isn't it? Just y equals 0. So that's just 0. So that part's just gone. So it's just b to the x times c. What's going to make it flip down? Where do I put the negative sign? Right in front of the b, huh? Good to there. It's got to have a negative in front right there. I made a vertical flip. Okay, what do you think the base is looking at the numbers? 8, and then 8 squared, 64. See, it's all about 8. 8 times 8, 64. It's all about 8. So you can just kind of spot that. So maybe, let's get rid of the c. Maybe it's just, often c is just 1. So I'm just going to guess. Maybe it's just negative 8 to the x. Let's try that. See how I came to that conclusion? I knew I had to have a negative in the front. I knew the base was 8 because we're talking about 8 and 64. Let's try it out. Put in a 0. What do you get? Negative 8 to the 0. What? Excuse me. So what's negative 8 to the 0? Are we good? That's a negative 1, huh? Not positive 1. Good. Negative 1 over 0 down 1. Is that on the graph? Yep. Over 0 down 1. Let's put in 1. What is negative 8 to the 1? Well, that's just negative 8. Over 1 down 8. Yep. Put in 2. Negative 8 squared. Negative 64, right? Not positive. Because, again, that negative is not involved in the power in any way. He's just sitting in the front. He's just a spectator at the games. I go watch my kids' games, baseball, soccer, that kind of stuff, and I'm just a spectator. I wish I could get on the field, but they won't let me. So that negative is just a spectator. He's not involved in the power thing at all. He's just watching the game, right? It's not involved. So minus 64. That's working perfect. That's the graph. Good. Question?
I was finding it a lot easier to just plug in the numbers like on a graph, and then you can figure out the equation like that a lot easier instead of having to look at the whole graph. If you just wrote down the points and looked at it.
Just write down the points? Sure. Yeah, whatever. Which is okay, can be used to find the number of milligrams of a certain drug that is in a patient's bloodstream 8 hours after the drug has been administered. How many milligrams would Okay, 1 hour. So hours, it says right here, is H. Oh, so that's easy. Just plug in 1. 2e to the minus 0.23 times 1. Hit the buttons on your calculator. That's all it is. Did you guys see what I did there? They just said 1 hour. They said H is hours. So right there I put in H equals 1. And then just hit the buttons on your calculator on that one. We have 2 minutes. Let me jump back. So that's all that one's going to be. Then 7 hours is the next one. Just plug into 7. Let's just hit the buttons on your calculator. Plug in a 1. Plug. So number 30. So H of X. So we've got, what is H of negative 2? H of negative 2. That means put it in negative 2. It's 1/3 to the negative 2 minus 27. Okay, so what is 1/3 to the negative 2? What's a negative power do? Flips it. So that'll become 3, right? Oops, scribbly. 3, and then the power will become positive. You tracking with me? See what happened there? The 1/3 flipped and became 3, and the power became positive. That's the rule for negative powers. I always tell my algebra students, negative powers, they're unhappy. They're negative. They're unhappy, like somebody unhappy at their job or something. They're going to jump to a new job. So that works, right? Negative powers, it's going to flip it, and then it's happy afterwards. Then the power is positive after the flip. So then that's just 9 minus 27, which is like negative 18 on that. And so now it says, what point is on the graph? Well, that means X we plugged in was what? Negative 2. And the Y that came out was negative 18. Does that make sense? That's what they mean by what point does that mean. Do you see what I'm talking about there? I plugged in negative 2, got out negative 18. Put in, right, X, Y, graphs, functions, plug in, get out, X, Y. That's what they mean. All right. That was a lot of math.